Hi, my name is Will Bastas. I'm a blacksmith. I've been blacksmithing for about 40 years. And I want to show you how I forge a pair of tongs. A pair of tongs that I developed the design, and it was originally from a photograph in a Centaur Forge catalog. And I didn't know the scale of it, but tried to copy it. And that's how my beginning learning in blacksmithing was just copying what I saw. It wasn't until later where I studied with some masters that I actually had technique and thought about the processes before I was forging. But back then, it was kind of knee-jerk. But these tongs, they're my favorite tongs. They're called Little Monkey Hands of Death with the new improved super groove. They didn't always have that long title. They were Monkey Hands, then Little Monkey Hands, then Monkey Hands of Death, then Little Monkey Hands of Death with new super groove. And then I thought improved would be good. Okay, enough of that. So I'm going to show you how I began, and I studied in Mexico with some blacksmiths down there, Augustine, and he showed me how to make tongs out of rebar, and I thought, oh, you can't make tongs out of rebar. But as our scrap yards closed up more and more, most of the scrap material got shipped to China for the Yangtze Dam project. I found coil spring harder and harder to find. Coil spring was my material of choice. It's tough, it's springy, and you don't have to heat treat it. Although you have to be really careful. You don't want to quench it in water, especially when it's hot, unless you want to crack it. So I found, studying with Augustine, that you can use rebar, and it has very similar properties. If you look at the classification, it's basically 4140. They're not going to tell you it's 4140, but it's 4140. So treat it like 4140. And if you want to use 4140, that's fine. A lot of blacksmiths don't feel like rebar is a good material because they think it's junk. Well, it's got code and it's got requirements of the composition, and it's just as stringent as any other steel. They also complain that the ribs on the rebar causes the material to crack or causes it to fold over and have shuts. Well, I found that I've never had that issue, and I've forged hundreds of pair of tongs with rebar. If it's got sharp edges, then you may want to choose another piece of rebar. But if it's radius edges like this, it'll be fine. They forge out. And whatever doesn't forge out, it's really nice evidence of what the material was to begin with. So I use rebar. It's cheap. It's readily available. Sometimes I find it in dumpsters and people just throw it away. So this is the pair of tongs I'm going to forge for y'all. This is the Monkey Hands. The new improved super groove is the fullered groove. Then it's split out, and I saw in a Bana article once on a pair of tongs that they had cut out, and I thought, well, that's interesting. But what it really does is that it makes these prominent, and there's nothing in the middle. If you look at farrier's tongs, rounding tongs, they look like they're made to hold a shot. But the principle behind the farrier's tongs is that they've got a hollow on the inside, so all of the edges are prominent, and this allows, whenever you hold onto something, it allows that those edges hold the material, not what's in the middle. The middle wears out last. The edges wear out first. So if you eliminate the middle, then you never have a problem with pivoting. So these tongs will hold a variety of different shapes. I've got a blade here that I'll be using later, and I use them for forging blades quite a bit. They're pickup tongs, but they're also tool tongs. So I've modified my tools to the point in time where these tongs actually hold on to the tools. So you have a pair of tongs that will put in the forge, take out of the forge. They'll hold tools. They will hold items that are odd shaped. You can hold on the diagonal. You can hold straight. You can hold perpendicular. So there's a lot of different variations, and I find that these are my go-to tongs. So this is what I'm going to forge for you. It's my mark, William Bastas, and like I said, my full name is William, but I'll go by Will. Okay, to begin with, I'm going to mark out a piece of rebar. This is number 6 rebar, 3/4 inch diameter, and it's been sitting for a while, but the rust will pop right off. I'm going to mark it at 20, but I'm actually going to cut 2 of them because I forged 2 irons in the fire. 3 is too much. 1 is too little, so I don't want the forge to be running without paying for itself. So I'm going to forge 1 pair of tongs completely for you guys, but really I'm going to be forging 2 pair of tongs, so I utilize the forge most efficiently. So there's 20 and there's 40, and I always lay out to avoid a cumulative error. So I just do the math on the tape. I could lay out 20 and then I could lay out 20 again. And in this case, it's not real critical because you can be plus or minus even an inch and they'll still turn out nice. But I suggest that you do the math on the tape. It gets a little difficult when you have 11/16 and you have to double that, or you have to half 15/16. But once you get used to it, then you get a lot more accuracy. So I saw this little setup at Peters Valley. I took some classes there, and I really like this portable bandsaw approach. So it's you have a tilt switch. Oftentimes you don't have to saw all the way through. You can nick and break, and that'll save you time. It'll save you saw blades. I do that frequently and when I'm working hot, but you can also do it cold. Okay, so I have the material for 2 pair of tongs, and oftentimes it's hard to believe that a pair comes out of that, but really that's the amazing thing about smithing. And one of the things I think about smithing is that it's a process, that it's a means to the end, and if it has to be forged, then you should use smithing. If I could fabricate these things, probably be faster. I wouldn't have to deal with the forge, getting burned, any number of things that are associated with dealing with heat and dealing with combustion of fuel. But in this case, this has to be forged, and the forging takes the material and puts it where it needs to go. It also refines the steel, and refinement is really something that you can't see, but you know it when you use them. And if they're refined, then you get the performance of the metal, you get the springiness of the reins, you get longevity on parts that if you're not careful with refinement, then you'll have large grain size. And large grain size, you don't see it until it breaks off. And then when you look at it, it's like, I got that too hot. So it's going to be important when you're forging, especially tools, and tools for yourself, but also when you start selling tools to other people, your tools have to be right. And they can't break and they become a dangerous situation. They can't fly off in a shard. You're also responsible for warranting your tools, and if they fail, then you're responsible for that. Now you have to lower your standards a little bit. You want to make the hardest hammer, you want to make the toughest chisel, you want to make, sometimes it's better to err on a little bit softer, a little bit less than what you possibly could get, because that way you have like this safety factor. So along with refinement, you also have to back up a little bit. So I'm not going to heat treat these tongs. I could heat treat them, and they would be really hard and really springy, but they might break. But what I am going to do is when I'm forging them, I'm going to make sure that when I heat it, it gets worked. And if I don't intend to work it, it doesn't get heated. So you always want to refine on the falling heat. And there's going to be some things that I want to talk about, and I'll go in further later if you guys are interested, but you need to refine on the falling heat, not on the rising heat. So when we forge at a temperature about 2400 to 2000 degrees, and in 2000 degrees to 1600 is you should start refining. You shouldn't really forge too much less than 1600. That's your transformation temperature on some of these steels, 1450 more or less on mild steel. But 1600, 1500, that's when you get your red heat, and that's when you want to do your final work, and you don't want to put that back in the fire if at all possible. Now, grain growth takes time, so if you accidentally heat something a little hotter than you want to, well, it's probably going to be okay, as long as, like I said, you lower your standards a little bit. But you can spot heat with a torch, you can spot heat with your coal forge, you can build your gas forges so that you can get a middle heat. You can also just pay attention to what's getting hot and what has been worked and what you don't want to incidentally heat. So a tenet that Uri Haffi taught me, Uri Haffi, master blacksmith from Israel, just an amazing man, but he works from the inside out. And I've I adopted that. So whenever I forge something, it's forged from the inside to the out. So I finished the forging at the end. I finished the initial forging in the middle, and so as I'm working, then I don't put the middle back in the fire. That's done. When you forge from the inside out, it's a little trickier because you have to anticipate how much material you're going to need. So you have to do some stock calculations, and I'll get into that in further videos as far as using clay to calculate stock requirements, using a scale to calculate stock requirements. But I'm set up, and what you want to do is you want to find the middle. One easy way of finding the middle is just balancing it. So I can find the middle. You can measure it, and that's fine too. But you can find the middle just by balancing. So there's the middle, and I'll make a mark, and then I'll just verify it with my tape. That should be 10. So keep that in mind, that there are some practical things that we do as blacksmiths. We memorize the width of our anvil, with the length of our anvil, the size of the holes, and they wind up giving us some idea, some intuitive idea of like the sizes that we need to forge, the lengths, and but also just real simple things like balancing. So on that ridge, which is the most prominent, I'm going to mark that at 10. Then it requires 3 inches on each side, and I've got some cheat notes over here, but it requires 3 inches on each side. So I'm going to go 7, and then I'm going to go 13. Again, I don't go 7, 10, 13. That's to avoid a cumulative error. You do the math here. Okay, so I can transfer this. This is not critical. If I were forging, I don't know, some tweezers or you know, typically we want to start off with more material than we need unless we have like a precise forging. And so a pair of scissors, maybe, you know, I don't know. We start off with more and then we trim later. So it's not super critical if I have a 1/16 of an inch on one side or the other. And I'm just going to transfer this. Oftentimes, again, as a practical way, what I'll do is I'll flip this around just to make sure that my dimensions are correct. That's a real simple way of checking yourself. You don't want to get involved with this and realize that one side's got 8 inches and the other side's got 6 inches for the rein. So this will be the rein, this will be the bit, or this will be the eye, and then that'll be the bit. There's a lot going on with that, but there's a lot of metal going on there too. So we want to displace that material. You could make a pair of tongs with this, but then you have so much weight to carry around. Heavy tongs are good if you're working at the power hammer, because the power hammer is going to have a heavy hammer blow, and that balances out the weight. You don't really want light tongs at a power hammer. Conversely, when you're forging at the anvil, you really don't want to carry around a lot of extra weight than you don't need to. So the trick is to put the metal where it needs to be, and that's where the master comes in, where there's every bit of material is supplied that you need. There's not a wasted piece of metal. Now, if they run long, I'll trim it. I can tell I trimmed this one. It was a little longer because it's a little thicker than that. So that probably went out to here. I like the reins to be even. So anyway, this is how I start. Now, that will burn off in the first heat. So the reason why I marked it on the ridge is that I'm going to find a place on the anvil that is sharp. And on your anvil, and we'll talk more about this later, but you should have a really good radius, about size, 1/4 inch radius, 1/2 inch diameter on either side of the part of your anvil that has the heaviest amount of mass behind it. And then you should taper off from there. So you should know that that's going to have a large radius. It should have a smaller radius here, and then really hardly any radius. Actually, I'm looking at this anvil, and my anvil is in North Carolina, and this is another anvil I picked up, and it's not quite radiused exactly how I want it to be radiused, but we'll get more into that later. I'll probably have to radius this, but I know that this is a larger radius. It's matched on both sides, and this is where predominantly I'm going to do my forging. And if I have a gradually decreasing radius, then I'll know that if I need a sharper edge or a cutting edge, it's further along here, right where there's no more support at your anvil. So I'll find the mark on a sharp edge, and I'm going to push the hammer into the stock so that the hammer defines the angle. Because if I go ahead and give it just a swing, I may not have the same angle as I'm holding. So I'm going to push against here again. So that makes that little mark, and I'll be able to see that hot. Again, I'm going to find the angle instead of letting the hammer define the angle. I'm going to let the bar define the angle. So you can see the hammer is defining the angle. And that way it doesn't send a lot of shock in my hand. This is rebar, is really stiff. So there's my second one. I'll make it more prominent so I can see it. And I'll flip it around. Again, if I'm a 16th off or so, it'll be fine. Blacksmithing, 16th and 8th. It gives you a little bit of leeway, because basically in traditional blacksmithing, you're going to be forging hot, and then you're going to be doing some bench work. And in modern blacksmithing, you're going to be forging, and then it goes to the machine shop. So, or your machine shop where you have your grinders and your files and that kind of thing. So one more time. So I've got my mark here, and I'll know that I can begin drawing my rein out here, begin drawing my rein out here. I draw the reins out first. And that's opposite from what many people do. But I draw the reins out first so that I've got a handle to hold on to. Those would be prominent hot because they're on that ridge. Okay, so I've got my stock ready to go. Now this is the gas forge I'll be using. I make my gas forges, and it's part of that heat, hold, hit, triumvirate that you need to have control over all three in order so that those are not a variable. Then you can focus on the shape, you can focus on the aesthetics, but if you don't have control over your heat, then you have a variable that's difficult to control, and then therefore your shaping suffers. So the first thing I do is I make sure that I've got a good heat, and I make these little forges. I make bigger forges. I made much bigger forges, but kind of settled on this size forge because for most of my little forgings, tongs, hammers, whatever, it's about 2.5 inches by 5 inches. And how I design these is I think about how big of the chamber I want, and then I build it out from there. So so in this case, it's heavily insulated. It's got Mizzou castable, and then it's got 2300 degree cable beyond that Mizzou castable. And oftentimes what I'll do is I'll put bricks on top of it. I took them off so you guys could see this forge, but I'll put bricks on top, and that's why I have all these bricks over here. And they give me additional insulation. Now the length of the forge, it's a fire brick long, and that's not by accident. It's so that I can put fire bricks on the side. So you can see I can line this whole thing with fire bricks. So typically when you see this forge, it's just going to be a pile of fire bricks, but I wanted to uncover it to show you the nuances of the design. I forged the Venturi out of 1.5" Schedule 40 pipe, and I neck it down using either powerhammer dies or using a spring fuller. We'll talk more about that later. And this is really not about building a forge, but the forge provides the heat for you, and therefore it's part of the tooling that you need in order to have good control, good efficient forging. So I like the simplicity of the Venturi. I neck it down to 3/4 ID, and then I open it back up to about 1.25" ID, and then I neck it down again. This gives 2 Venturis. There's a Venturi here, there's a Venturi here. In fact, there's 3 Venturis on this because as it goes into that street elbow, it goes from 1.25" down to 1 inch. So that gives you the velocity because of the Bernoulli principle. As you inject high pressure gas here, it entrains, creates a vacuum, and it entrains air into the side of it, and then it just keeps accelerating. Now it expands here, and my theory, and I'm not a combustion engineer, but my theory is that this gives it time to mix. So it accelerates, mixes. So this is my mixing chamber. It accelerates again so that it comes out a hole in the top of that forge. It's actually a MIG tip for a 30 thousandths MIG wire, and it makes it a lot easier than drilling the orifice that we call that the gas delivery orifice, but it's a lot easier. So if you can neck down down to 1/8 inch IPS, then you can put a MIG tip on that, and you can change the MIG tips out. And it's pretty interesting because even though it's a 30 thousandths MIG tip, so there's my MIG tip, if you put a tip cleaner in that, sometimes they'll be loose, sometimes they'll be tight. And it's nominally 30 thousandths, but that's an advantage because you can line them up to where the tip cleaner was the tightest and the tip cleaner was the loosest, and you can jet your forge that way. So if you're at elevation, you're going to want to lean it out because there's not enough oxygen. If you're at sea level, then you can rich it because you've got more oxygen. So it's just another way of like tuning your forge. But the nice thing about the Venturi is that there's no moving parts, and as long as you're careful about dragging stock in and out, then the forge will last a long time. And I take that Mizzou and I roll it up when it's wet. I roll it up with a piece of pipe, and that way it gives me these little berms on the side, and that KO wall is very protected. So it's really important that you avoid dragging some of that KO wall out. Now this forge is 9 inches, and on the other side it's got the identical doors. Now this one, I'll break a brick so that I have even smaller hole, and then this fits here. So if I want to, I'll go back and just plug that up. But so I'll plug that up sometimes just to get the forge hot. But this gives me a middle heat, so my middle heat is 9 inches. I could make it shorter, and then I'd have to take multiple heats for long forgings. I could make it longer, but then I wouldn't have the control of having a middle heat. So knowing that I've got these hard fire bricks back here and I can open and close them however I need them, that gives me control over my heats. So it's a little dramatic, but I'll get the forge going. I'll put some fuel in there, light it with a striker, and get it hot. Lock it up, and then it'll get hot pretty quickly. I'm done with my saw, so I'm going to get this out of the way. Now while we're over here, I want to show you just basically a schematic of where we're going. So these are little monkey hands of death with the new improved super groove, and I'll be abbreviating that here later. It doesn't make much of an acronym, but I like the name versus the acronym. So here's what I've done already. I've gone 7, 10, 13. I'm using number 6 rebar or the equivalent alloy. So 3/4 inch is going to be important to be able to provide the size of the eye that I want. These are some tongs that I forged out of titanium, and I actually didn't have any. I had 1/4 inch round titanium for a rivet. I forged all of my materials, so it's got a little bit smaller rivet that I like, but I like the size of an eye. It needs to be about 1 inch wide and 1 inch long, not much wider than that, not so much narrower than that. But if you don't start off with 3/4 of an inch, you're not going to get a 3/4 or a 1 inch eye. Now, everything on here, you'll see that I started off with 3/4. I made this material into the power hammer. It was a piece of rectangular bar, but I made a 3/4 inch round. But when you start with 3/4 inch round, you'll end up with 3/4 here. You'll end up with 3/4 here. And so it just provides the right amount of material. When I took a class up at the New England School of Metalwork, and I found a piece of rebar on the highway, and I said, I'm going to make a pair of tongs. And this was a number 4 rebar, not a number 6 rebar. So you can see that when you use the number 4, it makes quite a bit smaller eye. You can still see the reinforcement ribs in this. And it makes a nice pair of tongs, but a smaller pair of tongs. So this was number 4, which is about 1/2 inch. So you'll see the 1/2 inch there. You'll see the 1/2 inch here. You really see the 1/2 inch here. So if you want to make smaller versions of this, choose a smaller piece of steel. Larger versions, if you want to make longer reins, then you can lay out the same here as far as the layout, but just put 1 inch on each side. So you'll have 8 inches on each side, and you'll have 22 to begin with. You could make them shorter, but I've kind of settled on this length for my tongs. Okay, so we began with this, 7, 10, and 13, and I'm getting my forge going. And what I'm going to do is I'm going to draw out my reins first. You could draw out your reins by hand. It's going to hurt. I think 3/4 is about as much as you can hand forge. When you start adding the alloy to that 3/4, then you're forging some stiff material. So you better really get it hot, swing a heavy hammer, both, or have a striker if you don't have a power hammer. Treadle hammer, not going to be as useful. Fly press, not going to be as useful. These are tools that very controlled hits, but not a lot of them. Blacksmith's helper, not super handy. To make tongs, but a lot of tongs, it's going to be a lot easier if you're going to use alloy to if you can draw out your reins first. If you've got somebody that has a power hammer, just draw your reins out. You can do the rest of the work by hand. All of the eye and the bit, all of that, you can save some unforged stock. Just draw your reins out, and then you can have a lot of blanks. So what I'm saying is, how do you get around not having a power hammer? That's a difficult thing. So I decided I was just going to bite the bullet, and I bought a Seha, and it was $7,500 when I bought it, but they've gone up quite a bit, and it's a good machine. I also have a 100-pound Little Giant. I've got a tarp on it because even though my shop, here's my 100-pound Little Giant, and I'll be working with my 100-pounder. It's got flat dies on it, and I put drawing dies on the Seha. So this I'll use for certain applications, but today mainly for the drawing out, I use the Seha. Alright, my forge is getting hot. I'll go ahead. Now forge, you should have a telescoping tool rest so that you don't drop your stock. That were my quench tank. That would be the worst thing to happen with some alloy steel, is to get it hot and drop it in a quench tank. That's happened. I'll reach into that quench tank, and I hope that I'm grabbing the right end and pull it out as fast as I can, put it right back in the fire. So the best thing to do is have control over what holds your stock. So these are going to get longer, and as they get longer, I'll need to control that stock. Now, I'm going to take a heat that's an inch or so longer than what I need, and I call that a reserve heat. So if you don't pull a reserve heat, then your initial forging, it's going to be really stiff. So pull an inch beyond what you intend to forge. So the forge is 9 inches long. I need 7 inches. I put the tongs all the way into the forge. Now, when I use the power hammer, I'm gonna act like it's just a couple people hitting with a hammer, and I'm gonna hit the whole thing with those hammers going, and then I'm gonna pull it all through the hammer. And let me illustrate that with this bar. So my hammer rocks a little bit. I know some people are going to complain about that, but it gets I haven't like fully resolved where it's going to be, and I think it's going to move it this way. That's why I have the chain hoist here. But for now, let me just explain to you what I'm talking about. So I'll turn the machine on. Make sure you have inventory of your hands before you start going anywhere near the dies. So when I pull this stock through the machine, I'm going to pull it through. That did this much, and you can see that it knocked the paint off. The next time though, so all of this has been hit once. The next time though, I'm going to skip an inch, and I'm going to hit all of this once on both sides. Okay, so that's been hit. This has been hit once, that's been hit twice. Then I'll skip an inch, and I'll hit this 3 times. I'm demonstrating this cold, but this is what I'll be doing hot, and I want you to see it when I'm forging it. So you'll see the principle hot. I hit this once. I hit this twice. I hit this 3 times. I hit this 4 times. I hit this 5 times. This is something I learned from Sir Saddam, Israeli blacksmith, fabulous blacksmith. It makes stair steps, and you'll see it. It'll stair step it down. I'll draw that material out fast, then I'll planish it with the same heat. So basically, I'm taking 7 inches. I'm going to turn it into 11, and then I'll wind up, after I planish it, I'll wind up having about 12 inches long. So if you wanted to, you could start off with a longer bar and then forge the end, so you wouldn't have to use a pair of tongs. And I'm thinking from a perspective of, if you didn't have a pair of tongs, how would you even start? So I'm going to use the monkey hands of death to hold this stock, because the reins have so much spring to them, the bits have spring to them, the fact that it's got a deep fuller groove allows it to hold unusual stock. I'll use a tong clip to hold on to the steel. So if you can't get your tong clip on here, then you put it on here. And you can pull it back, and then now the tongs are holding onto the steel, and I'm not fretting about holding onto the steel. It's a really strong hockey idea. So I've got my heats, and I'll show you. There's my heat, a little bit cold on the end. There's my inch of reserve. I need a little bit more heat. But if I wanted to, I could get started with that and just not forge the end. Leave what's called a bulb on the end. I want to do some power hammer videos, and I want to discuss what I mean by leaving a bulb. But today I'm just going to forge that simple taper idea where you have stair steps and you assure yourself that you have a taper because of the sequential action of pulling it through the dies. I'll let that heat up just a second. And just make sure that when you're working at the hammer, that you hold everything level. And you may take a light hammer blow first, just to make sure everything's level. Now these are drawing dies, they're crowned. And in fact, these aren't really perfectly crowned. There's a third in the middle that are flat. This is a neat die design. So right across, right here in the middle, let me draw this with flat. I didn't design these. It came with the hammer, but it's probably arguable as far as who came up with this idea. I heard they were California drawing dies, some big hammer guys in California, but it's flat here, and it drops down about 5 degrees here, and it drops down about 5 degrees here. And what that flat area does, it assures you that when you're pulling your stock through the dies, it planishes it flat. If these were crowned the whole way, there'd be no way of making it flat, because you'd have to pull the stock through per hammer blow so incrementally in order to flatten it. But being about 3/4 of an inch, then these dies are 2 by 4.5, I believe 5. But by pulling it a little bit less than 3/4 of an inch, then you have both drawing dies and you have planishing dies. So just keep that in mind with this. They're not crowned; they are designed so that they drop from the sides, but then they're flat in the middle. Okay. So now that we've got that, I always wear hearing protection, and so I've got these little pink earplugs. I get them at they're for women because I have, from what I understand, women's small ears. So you put your earplug in, pull your ear up so that it straightens up your ear canal. Squeeze this. It's going to get dirty, but it's going to get dirty. And put it in here. Now this will save your hearing. It's not perfect because you may have some sound transmission through your bone, but it's a sacrifice. You may have to choose this blocks out most of the sound. Otherwise, I would use earmuffs. I've got some earmuffs around here. Earmuffs, they protect your hearing through the bone loss. But I have a tough time talking with the earmuffs on, so I'll use those on my own. For the video, I'll use the earplugs. Okay, so here's that nuanced draw. There's my mark right there. I'll hit it right to make sure I'm level. Okay, so that's all been hit, except for a little bulb on the end. We'll talk more about that later. Now skip an inch. Bulb stores heat. And I'm going to light the bulb back up. I'm going to flange the whole thing. And there's my taper. And it's a pretty even taper because I hit once, I hit twice, I hit 3 times, 4 times, 5 times, left the bulb, and I was able to light that bulb back up. Now with the remaining bit of this heat, on the diamond to make an octagon, and it's not an octagon until all the facets are the same size. Now this facet is wider than that facet, so if I want to hammer polish, I always forge it on the diamond a little bit wider, and then I'll go back on the original flat and I'll hammer polish it. It's hammered very lightly. Let me show you the difference between a hammer polish and not hammer polish. This is hammer polish, that's not hammer polish. Hammer polishing, it refines the texture you get, the oxidation texture, into a forged texture. It also crisps up your edges. So this is a hammer polished octagon that's been drawn from basically 7 to 11 or so. Then I forged it on the diamond, hammer polished it, and that gave me about 12 inches. It's not real critical, but the dimensions, as long as they're all forged, they're all about the same. So, okay, so there's 7, there's 3, that's 10, that's 3, and then that was 7. So that's forged. Now I won't say anything on this one, and you'll see those procedures that I just outlined. I can always go to the ridge. I know where my mark is going to be. It's going to be on one of the ridges or the other, and it's right there. that the dimension that I have, here's where the forging started, and here's where it ended. And if you're consistent with how you approach your forging, then you'll have the same result. So while we're buying some time, I just wanted to show you. This don't always turn out that way. If it doesn't turn out, I hide it under the anvil. But when it does come out, I like to illustrate. So now, we talked about this earlier, that I want to make sure that the fuel that I'm burning in there is burning efficiently. So this one's ready to go. I'm going to have to go with those really small pair of tongs. This and let's see. That's good. Make sure that your tongs fit. Since it's a smaller, and these are another pair of monkey hands, they wind up having a little bit smaller, fuller groove, so they hold on to this fairly well. Make sure you back up your stock all the way to the back of the tongs. It's holding here, and it's holding there. And find a tong clip that is small enough. Talk about how to make these tong clips, or just make your own tong clips. And find it so that it's small enough. Now, I like for the stock, I like for the tongs to follow the same line. Whether it's these are a little cockeyed, I'll have to look at that. It's right here, but I'll talk about that when I adjust my tongs. But if this follows the same line and it doesn't drop, it drops a little bit, but it's not too bad. I can adjust for that. If it's way off, then it's hard to adjust that at the hammer. So I'm ready to go on this. I'll do the same thing. I want to talk about not only striking while the iron is hot, but striking where the iron is hot. So this is going to lose its heat, and that will eventually lose its heat. But if you neck it down, then what happens is when I hit this again, the friction is going to create heat, and the heat's got nowhere to go, and so it'll light up the bulb. So when the bar falls out of your tongs and it lands on your boot, you got to act like, I meant to do it that way. Braden was working a little bit further than my tongs clips was, but I wanted to show you that concept of that isolation, the necking down, and I think that's really important. If you keep that in mind, then you'll forge to finish where you have the heat, and then where you have already planned, then you go back into an area and you either light it back up, or if I needed to bring that last part back up to heat, as long as this was forged to finish and I only need to do that, then I don't have to reheat this area again. So this is the idea behind grain refinement. I want to make sure, and that I guarantee that grain is refined after I forged the taper using that step technique, broke it on the diamond into the octagon, beyond the octagon, so that when I went back into the original square, I could polish the steel, hammer polish the steel, crisp up those edges. I was working at about, it's pretty light in here, but I was probably working at about 1400 degrees. I'm going to get some incandescence there. You're not going to see it with all of the light that we have. It's still going to be non-magnetic, or just at the point of non-magnetic. You'll get to a point in time where you know how far you can push it. If I pushed it another 10 seconds on the steel, and that's why I didn't take this last one, it's quite as far, because I talked about it, I pulled it, took it off of the hammer. I didn't want to take it because I know that if I went down to about 1300, 1200 degrees, I'd be in the brittle black, give it a crack, and that doesn't make for a very good, instructional video. You want to show how it's done, not how it's supposed to be done. Well, you know what I mean, it broke, but no, it needs to be right. So you'll get that experience with the different steels that you work. Some bladesmiths call this packing, and I'm not afraid of working it right at that transition temperature. And like I said, 1450 for mild steel. You'd have to have a magnet to see when you get your magnetism. Typically, it drops a little bit below 1450 to get your magnetism when you're on the falling heat. When you're on the rising heat, it has to go a little bit higher than 1450 in order for it to become non-magnetic. You know what it feels like when it's above transformation temperature and it's still moving. Try not to forge it too far below that, but you can rationalize it through this concept of grain refinement and packing.